Now, growth during infancy is more rapid than any other period after birth. Infants will double their weight by about 3 months and triple their weight by about 1 year. But these are just averages, you know. Every child is unique, and there's a lot of factors that play a role when it comes to how quickly your child will develop in different areas. So when we talk about these average growth rates and things like that, I just want you to understand that this is not like a judgment we're passing here. We're just saying we've looked at all the kids, and these are the things that we tend to see. So if your child isn't growing at the same exact rate, there's nothing wrong with that. You know, average and normal are completely different ideas. Like, for example, one of those big factors that plays a role in growth rate is heredity. Like people from Asian cultures, for example, do tend to be a bit shorter than people from other cultures. And when we do look at the growth of an infant, what we generally see is that different parts of the body grow at different speeds. Like the head, for example, tends to grow a lot less than the rest of the body. And this is something everybody already kind of naturally understands, like instinctively understands, but you don't really start to notice it until you look at like art and animation. Generally, when you see characters with like a massive head on a tiny body, those characters are cuter, typically. They're more endearing because that's mimicking the proportions of a baby. Like when it comes to baby body proportions, a infant, a newborn, is about 4 heads tall. So if you were to take their head and stack it up 4 times, that's how tall they are. But once they get to about 3 years, now that proportion has changed. So now it's 5 heads tall. And then by 5 years, it's 6 heads, and 10 years, it's 7 heads, and so on, until you get to be an adult. And most adults are about 8 or 9 heads tall. So the proportion of head size to body size changes dramatically over those first like 20 years. And I studied art history when I was doing my undergraduate work, and I always thought it was really kind of creepy and unpleasant when I would look at some of these old artworks, because these artists clearly didn't understand these proportions. Like you saw somebody who had adult proportions of head to body ratio, but they were baby sized. And that just looks wrong. It looks like a little doll. It doesn't look like a baby at all. So when you do see characters with big eyes and big heads, keep in mind that the reason for that is the artist is trying to make you think of this character as more of like a baby, basically. Like just think of the Bratz dolls, and that's what I'm talking about. They're trying to make the character seem cuter. But here's those averages I mentioned earlier. So average growth rate in height. So you can see the years going across the bottom and the height in inches across the y-axis. So for boys, this is the pattern we tend to see. So they grow pretty steadily, but those first couple years tend to have the most rapid growth, as you can see. And then growth will kind of flatten out sometime shortly after puberty. This line represents the growth rate for females. And you can see their line flattens out a little bit sooner. It flattens out pretty much right on top of puberty. Most young girls will not grow very much taller after hitting puberty, whereas boys will continue to grow into their teens. And then here's the average growth rate in weight. So you see weight in pounds across the y-axis, and then years across the x-axis. And it's basically the same story. There's some pretty rapid growth in the first year or two. After that, it's kind of steady, and then it will flatten out sometime after puberty. For males, it usually starts to flatten out a bit later than females, but not much later. So after hitting puberty, after most people will hit puberty around this point, after hitting puberty, both males and females will continue to put on weight throughout those teen years, typically. So, one thing that's very important that fuels that rapid growth rate early in life is the how much nutrition these babies need and will try to get. Babies are always sucking on things and trying to eat things. This rapid growth does require a lot of calories. And typically, when it comes to feeding a baby, we strongly prefer breastfeeding. If you can breastfeed, if it's possible for you to breastfeed your baby, you should. That's what we recommend. It helps to ensure proper nutrition. It helps to build the baby's immune system. Like the mother can literally give the baby her immune system. I'm not sure exactly how that works, but she can pass on some of these immunities to the baby through the breast milk. Also, breast milk is easier to digest. It can help to filter out contaminants in the water. And for some reason, babies seem to more easily transition to solid foods if they've been breastfed. Bottle feeding, on the other hand, does have some advantages. It's much easier to provide for multiple babies. Like mothers who have twins or triplets or something like that, they can literally be sucked dry. Like they will run out of milk. And in that case, you don't really have much other choice besides, providing the formula. Another big benefit to breastfeeding, or bottle feeding, is that anybody can provide it. So if mom's not around and the baby's hungry, well, there you go. Dad can prepare it for you. Also, bottle feeding helps to prevent the transfer of some teratogens. Like if the mother is sick, if the mother has a virus, for example, that could potentially be transmitted through the breast milk. So in that case, it's much better idea to use formula. And when it comes to which formula to choose, there's a lot of options out there. But I just want to assure you, we have standards for these kinds of things in our country, thankfully. So even if you buy the cheapest stuff out there, I want you to understand you're giving your baby good quality stuff, okay? You don't have to buy the super fancy stuff that's natural and organic and all this stuff. Just the cheap stuff is perfectly fine. There's nothing wrong with that, okay? Now, if you do breastfeed your child, we typically recommend that you try to do this for at least a year or two. That's a healthy amount of time for a child to be drinking his mother's milk or her mother's milk. But when it does come time to transition to solid foods, generally what we see is that children tend to be picky eaters. Growth will slow as a result because they will desire certain kinds of food and just outright reject other types of food. It takes them a while to learn to try new things. And if you are a parent of a finicky eater like this, there is some advice that psychological science can provide for you. First of all, use operant conditioning. So reward, for example. Reward healthy eating behaviors. If the child eats the kind of stuff that you want them to, give them a sticker. Give them like a little candy. Provide them with some kind of reinforcement for that good behavior. Another thing you could do is take advantage of observational learning by modeling proper eating behavior. Most parents naturally already understand this and will do it. It's where you just eat the food and you smile and you're like, oh, it's so delicious, you try it, that kind of stuff. That's what I mean. So modeling that behavior you want to see tends to, help produce it. Something you could do as children get a little bit older and they start to be able to communicate with you better is you could actually explain to them why it's important to eat certain kinds of things. Teach them the importance of nutrition and teach them how different kinds of foods help different parts of their body to function and what will happen if they don't get enough of it. But the most important word of advice we can give you is to just be consistent. If a child rejects the food, don't freak out about it. Don't get angry about it. Just keep trying. If they reject it, try again later. If they keep rejecting it, just keep trying again later. Eventually, you should be able to wear that child down and have them actually try the food. And more often than not, when a child tries something that they've never had before, they do tend to at least find it interesting. It's quite common for children to reject food, really angrily for a long time, and then when they try it, now they love it. So just keep in mind you need to be consistent. Don't give up. But an interesting side note about finicky eating is it actually seems to have some evolutionary value, some survival value. Because if you think about it, it can actually be a pretty bad idea to just go around eating whatever you come across. That's a good way to get poisoned or, suffer in some other way. So children who are finicky eaters, they're basically demonstrating a survival skill. That's just kind of an interesting observation. But on the subject of eating and nutrition, the unfortunate truth is that a lot of kids just don't get enough. Malnutrition is a very common problem worldwide. About 1 in 4 children are malnourished. And you can just define malnourishment as not having developed enough for your age due to inadequate nutrition. And if you think back to those growth rates charts I was showing you, that rapid growth rate in infancy, that's where malnourishment has its strongest impact. So if an infant is not getting enough food, that child will be stunted for the rest of their lives in most cases. And the problem with dealing with this situation, because we have tried many different techniques, people are trying all the time to help find these kids and give them enough food to develop properly. The problem with this is that malnourishment produces a unfortunate consequence of the child just being kind of listless. Like when you're out there looking for these kids, they just kind of fade into the background. They don't call attention to themselves because they don't have the energy to call attention to themselves. So this just results in them not always getting noticed, unfortunately. But let's change the subject to something less upsetting. The brain and the rest of the nervous system consist of cells that we call neurons. I'm sure you remember hearing all about neurons previously. And these are the basic cellular units of the brain and nervous system, specializing in sending and receiving information using electricity and chemicals. And when it comes to the neurons of a developing child, they actually do some pretty cool stuff. So as the child develops prenatally, these neurons will actually move and form structures and change their shapes over time. So this all begins very early on in development. One of the first body structures to develop in the womb is called the neural plate. This is a flat group of cells present in prenatal development that will eventually become the brain and spine. If you remember from a previous video, the brain and spine are the first 2 structures to develop in this embryonic stage. And as this further develops into a more complicated structure, you will start to see neurons just kind of spreading out and moving in various fashions. This movement is what we call neural migration. And they do it through a few different methods. Like one method is kind of like, just imagine these neuron like reaching out and pulling itself along to where it needs to be. It has like a little hand or a little foot to pull itself. And another method that they use is kind of like pipes. It's kind of like tubes, like they're just kind of pushed along a path using glial cells. But these early neurons, these proto-neurons, so to say, they're immature. They don't look like neurons. They look like just generic little body cells. It's like a little bubble with a nucleus in the middle. There's no dendrites. There's no axons. It doesn't at all look like a neuron yet. But when it gets to where it needs to go, that's when it will go through the second process of aggregation. So this is where they will start to clump together and then start forming those connections. So those connections, what I mean by that is they'll start to develop dendrites and they'll start to like reach out their axons towards other cells' dendrites. And the way it does that is actually kind of neat. We're still doing a lot of research on exactly how that works. But just think of like this, think of this axon that's reaching out. Think of it as like sniffing for chemical signals. Like it's searching for that dendrite using chemical signals that it can kind of like smell, so to say. And all these connections will start to develop pretty rapidly. during the prenatal stages. But the number of synapses will peak at about 12 months after conception. So shortly after shortly after children are born, you'll see a huge amount of synaptic connections. And this is when synaptic pruning will occur. Synaptic pruning is a perfectly natural process, and the purpose of this seems to be to improve the efficiency of this newborn's brain system. It involves the gradual reduction in the number of synapses beginning in infancy and continuing into early adolescence. So, and besides this cleaning up of synapses, we also see a cleanup of unnecessary neurons. Approximately 50% more neurons are created than are ultimately needed. So neuron death is perfectly normal. So here's the best way to think about this. Just think of, when a newborn is at this 12-month milestone after conception, this represents the peak of developmental potential. There's so many different ways that this nervous system could develop, and how it develops is heavily dependent on its experiences. So as this child grows up, goes through the infant years into the child years and teenage years, the brain is adapting, the brain is adjusting to those kinds of things in the environment that are important. So if certain things never are exposed to them, then those parts of the brain for those kinds of things will just be deemed unimportant and will just naturally kind of fade away and die off. Those connections will be severed, those cells will die. It's all about improving efficiency. So newborns are like the peak of efficiency, but newborns are the peak of potential. They have a lot of potential, but they're highly inefficient. Whereas adults have relatively little potential for growth, but high efficiency. That's the result of all this cleaning up. But it is pretty hard. We do know some stuff about the infant's nervous system, but it is pretty hard to study their nervous system for a number of reasons. We have various kinds of imaging techniques like electroencephalography or EEG. That's the study of brain waves recorded from electrodes that are placed on the scalp. So just think of a little infant's head, and you can just stick these little things onto its head, and then you can see the pattern of activity in those parts of the brain. So this is a great method for studying infants because it doesn't require them to be very still, and we can show them various stimuli and see how their brain reacts. But like I said, we don't really think of this as brain imaging. We don't really have very good imaging methods of the infant brain, because the standard techniques like fMRI or PET, functional magnetic resonance imaging and positron emission tomography, these methods use magnetic fields to track blood flow, and they require the individual being scanned to be still, to remain motionless for a long period of time. And that's just something newborns are not going to be able to do. Well, when they're asleep, they're still, but you have to be awake during these scans. Otherwise, it's not going to be a very good scan. So to be awake and to be motionless, that's just not really going to happen with a newborn. So this is a big challenge. We need to develop better methods to try to understand the newborn brain. But other methods have been used in the past. Some of these methods are still used to a certain extent to try to understand this shaping, this early life shaping of the brain. Like researchers in the 60s and 70s, these researchers did a series of what we call visual deprivation experiments, where they would raise newborn animals, typically cats, because cats' visual system is pretty similar to human. They would raise cats in a visually deprived environment. Like, imagine an environment that had no vertical lines whatsoever. Like, the only thing you ever saw were horizontals. They would create these kinds of weird environments like that, and then raise the kittens in this environment and observe the effects. And the effects were that their brains were undeveloped. They didn't They lost that potential. Remember, the synaptic pruning and the neuron death, that's all about increasing the efficiency of the newborn's brain in order for them to interact with their environment better. And these kittens, they never were exposed to vertical lines, so that part of their brain literally died off. They were incapable of seeing it. So these kittens clearly showed some pretty severe deficits by being exposed to these kinds of environments. Whereas on the other hand, we've also done studies where, like, imagine like little rats, for example, are raised in environments that are highly stimulating. Like, there's all kinds of stuff for them to explore and learn from, and there's other individuals for them to interact with. By being raised in these enriched environments, we saw a lot more development. You know, that potential I keep talking about was not as, it remained. You know, the brain didn't lose those potentials because these little baby rats were exposed to those kinds of environments. So there's just more synapses, more neurons, etc. Greater dendritic development. So what we can take away from these kinds of studies is how important it is that you expose your child to the kinds of things that you believe are important for their development. It's important for them to get a lot of intellectual stimulation, a lot of visual stimulation, and auditory, and so on. So if you want to make sure your child develops properly, just make sure they have an enriched, interesting, interactive early life environment.